All right. 11.4, areas of regular polygons and composite figures. Everything before this, in this chapter, we were talking about areas of circles, triangles, stuff that was really easy that you've known for a long time, right? I know that some of those questions got a little bit harder, but overall it was pretty easy concepts. I don't want to intimidate you. I don't want to say this is difficult, but it is new for you. So it's not going to be as easy as the other sections were for like a day, okay? So what we're going to do is we're going to take the notes. We're going to take our time with it. I'll go slowly as you need me to. I'll give you an assignment. It is in the book, but I'm going to provide the work with the answers just to make sure you're on the right track when you're not with me, okay? And then on Monday, what we'll do is I'll go over any questions you might have, and I'm going to give you a worksheet over the same thing. Does that make sense? So I don't help on the worksheet, but I'll help on the homework. So if you actually do the homework and you know what you're doing, the worksheet will be a breeze. Does that make sense? So it takes about 2 days for you to really understand this section, in my opinion. Okay, so give me some time is what I'm saying. All right, so first we have to remember what regular is. What's a regular polygon? All the angles and all the sides are congruent. All those other things are right, but that's what I was looking for. So if you've forgotten what a regular polygon is, you might want to make yourself a note really quickly. It says all angles, all sides are the same. Okay? Because if you don't know what that means, then the rest of this isn't going to make too much sense. All the angles and all the sides are the same. That's a regular polygon. And yeah, you were right. It's closed and da-da-da. That's all still true, but okay. So we need today for when it doesn't have its own formula. So like if it's a, I don't know, if it's a parallelogram, we're going to use base times height still, right? But today we're going to have pictures like this where I don't know a formula for the area of that shape. Okay, or I might still have a triangle, but they don't give me enough information to do base times height, half base times height. Do you see what I'm saying? So we have to know this for when we can't use the other options. Okay, so the regular polygon, the formula for the area of it is 1/2 times perimeter times apothem. I assume that's new for you, okay? So area is 1/2 PA. As long as it's a regular shape, you can use this formula, all right? Apothem is a segment drawn from the center of a regular polygon perpendicular to a side. So on this picture here, from P to B, this is the center of the polygon. It's making a perpendicular to the side. This is my apothem. Okay? Mm-hmm. This isn't the radius, this is, and that's what we're going to talk about right now. Okay? So PA, line segment PA, is a radius. Even though there's no circle here, I could draw one, couldn't I? If I drew a circle around P, then PA would be a radius. So would PC and so on and so forth, right? And then PB, we just said, was the apothem from the center to the opposite side, making a right angle, okay? AB and BC are the same. When we create the apothem in a regular figure, then we've created two congruent triangles, okay? And then angle APC is my central angle. This angle here is my central angle. So that's just kind of labeling everything. Is that okay? Okay. So this is a regular shape. How many sides are there? 5. So what that means is I could make all 5 of these triangles, this big one here, not the PB, like pretend that's not there for a moment, okay? I can find this central angle. If I draw a circle here, how many degrees are in a circle? 360, right? So if I want to know each of these central angles, because they're all the same, how would I find them? 360 divided by 5. Very good. That's what's going to be on this next page here. That's what we just said. The central angle of a polygon is where you take 360 over n, where n is the number of sides. So we just said 360 over 5 on that particular picture. Okay. So the central angle of a polygon is formed by two consecutive radii, two radiuses, if you will, right next to each other. So the central angle we already talked about here, because this is a radius and this is the consecutive radius, the one right next to it. Is that okay? Okay, so now let's actually do some. Identify the center, radius, apothem, and central angle, then find the measure of a central angle. Only find one because they're all the same. Okay, so what is the center of this shape? Capital R, point R. What's, there's two radii that they show. What's one of them? Line segment RK and line segment RL. Easy, everybody fine? Okay. Apothem, where is our apothem? Line segment RS. Everybody good? and then name the central angle, angle KRL, and then we're going to figure out what it is. Before I do that, did I lose anybody up there with naming everything? Okay, so we're going to do 360 divided by what? Bless you. 6, which is 60 degrees. Each of these central angles, this angle here, bless you, it is 60 degrees. Okay? Pretty easy for that part, right? Anybody still need that? So your line, the first line was the name and the second line was the degree, because the second part of the question was find the measure of it. So the 60 degrees goes in your second blank. Okay? Find the area of each regular polygon. Because they told me it's a regular polygon, I know I can use, or I probably am going to use, area equals 1/2 PA, 1/2 perimeter times apothem. So I need the perimeter of this figure, and I need the apothem. I have neither. Do you guys see that? That 5 is not the apothem. The apothem, I could draw it here. Let's see here. I could draw it here. I could draw it here. It doesn't really matter. Just pick one. I'm probably going to stick with down here, though. Okay? Just know that it doesn't matter. So I need to find some stuff. So what I'm going to find first is my central angle. I'm going to draw my central angle, right? So that's my 360 divided by however many sides there are. So I'm going to say central angle, so I know what I'm doing, right? Is 360 over how many sides do we have here? 5. So my central angle is 72 degrees. So this is 72 degrees, this whole piece. Okay? That doesn't help me too much. So what I need to realize now is that if I'm looking for the apothem here, okay, I'm going to need this side for perimeter eventually, and I'm going to need apothem. Remember when I said when we cut it down the middle, we created 2 congruent triangles? So I'm going to take this triangle and draw it down here, because that's hard for me to see up there. What was this, 72? And then apothem, I don't know what it is, but I know that this is 5. Do you guys see how I took that triangle and I drew it somewhere else? Okay. If this is 5, then this is 5. So you can have 5 on either side. You can have 5 on both sides, whatever you prefer. Is everybody okay with what I just did? Okay. I need apothem, and I need this. I'm going to split that triangle and just look at the right side of it. If this was 72 as my central angle, what's this one? 36. Very good. This is still apothem, and this is still 5. So you guys see that I took the central angle triangle and I cut it in half. So now what can I do to find the apothem? SOHCAHTOA, right? It's got a 90-degree triangle, so I'm going to do SOHCAHTOA. In case you forgot, all right? So from the 36, what is A? Opposite, adjacent, or hypotenuse? Adjacent. It's not adjacent just because it's an A. Don't think that, okay? And then what's the 5? Hypotenuse. So I'm going to use cosine of the angle 36 equals adjacent A over hypotenuse 5. Pause there. Is everybody okay with that? Okay, obviously we need a calculator now, especially if you have a graphing one. Make sure you're in degrees, because this is degrees. Most of your scientific should be fine though. So we're going to multiply both sides by 5. So you're going to take 5 times cosine of 36 and tell me what you get for A. Yeah, 4.05, something like that. Don't clear it out. Put it back in if you got rid of it, okay? Get that 4.05 back in. So I'm going to start replacing things with what they are. I'm going to start substituting. A, we just said was 4.05, but I'm going to put a star there. You don't have to do this, obviously, but I'm going to put a star there just to let myself know it's not really 4.05. It's going to be whatever I store in my calculator right now. Okay, so we're going to store the 4.05 in our calculators because that's a rounded answer. I don't want to round and round and round, right? If you've forgotten how to store, you want to stow and probably A for most of you. Some of you guys have an option where you can go up and highlight and grab it and bring it back down later. That's fine too, but just make sure you at least let yourself know it's 4.05 so you know what you're grabbing later. Okay? So now what do I need? I have my apothem. The perimeter. I'm looking for perimeter, right? So I'm looking for this side. Well, if I find this piece, let's call it X for a moment, what would I do with it? Multiply it by 2 first. Yeah, I see what you're saying though. I'm going to double it to get a whole side. If I double it, I've got one whole side. How many sides are on this? 5. So then I would multiply by 5 to get the perimeter. That's the point, okay? So let's go ahead and find x. What am I going to use? Sine, cosine, or tangent for that? We've got opposite and hypotenuse from the 36. So sine of 36 equals x over 5. Do you guys need me to go back over that? Are you okay? Okay. How do I solve for x? Multiply by 5 on both sides? So get it in your calculator. Don't get rid of it. What do you get for x? Yeah, I got 2.94-ish. Okay, but keep it in there. That's just this piece, right? That's just this piece. So I'm going to double that, and I'm going to multiply that by 5 to get the perimeter. So what do you get for that? 29.4-ish, right? Keep that in your calculator so we don't have to store it, okay? You should still have the 29.4 in there. So, yeah, it does. I'll show you. So we'll do the 29.4 that's still in there times the 1/2 times the recall 4.05. Okay? So my total, I understand everything answer should be 59.4 centimeters squared. I want you to take your time and get there, and if like the storing is an issue, I want you to come over and show me your calculator. I'll help you. If storing is intimidating for you, first of all, I want you to be more comfortable doing that eventually in your upper level math classes. This will be so easy for you. You'll just plug and chug and you'll be fine. But we have to start somewhere. If this is intimidating for you, technically you could write down like 5 or 6 decimals and use that. I just eventually would like you to not have to do that. Okay? So come over if something's not working. On yours. You're not able to go up and highlight though, right?
No.
Yeah.
I don't think.
And I know you have an answer button, and that's helpful sometimes, but the storing on this one, I think we had to Google it because it wasn't as easy as everybody else's.
It was like shift, and I pressed store, but then
So where is your store?
it's right there.
There it is. Okay. Shift stow. Let's do like 2 plus 2 or something. 2 plus 2 is 4, right? So we're gonna store it under. How did we do that? It was in red, but I think I just pushed it. Enter. So let's try this. So let's do 4 plus recall right here. And I want the A back, so I have to push the red A. I'm going to show you what I just said again, because that was a lot, right? So if we want to store 4, right, you do your stow, so your shift stow, and you literally just push whatever, like A, B, C, or D. Like I'm just going to push A. Even though it's in red, I don't have to do that, because it's ready to store it, okay? So if I want, we said 4, so let's say I want 4 times the 4 I just had. To recall, you do recall, and we had A in red, so I've got to push the red to get that, whatever answer we had back. Cool? Okay? I know, it's not as easy as the other ones. Yours is the same. Yeah. So, like 2 plus 2 is 4. Let's pretend we want to store that. So we're going to see store in yellow. So second, store A. You just push the A the way it is. Okay? So if I want to do, what do we store for? Like 8 times 4, right? If I want to recall, I push my recall. It's in white, so just push it. And I want the A that's now in red. So, cool. And you have an answer button too if you're just going to use the one you just had in the calculator, but it wouldn't do like 2 above. Everybody good? Okay. All right, this one, find the area of each figure, round the nearest tenth if necessary. This is where the title said composite figures, but we haven't talked about what that is today. A composite figure is something where it's 2 or more shapes together. Okay? This is not a regular shape. How do I know this isn't regular so I cannot use 1/2 PA? Not all the sides are the same, right? I've got a 10, I got a 12. That's not regular. Okay? So what shape is here? A rectangle. And what shape is here? A triangle. So I'm going to find the area of this rectangle. I'm going to find the area of this triangle. And what am I going to do with them? Add them together. Right? So what is the formula for the area of a rectangle? Length times width. Sure, fine, right? So I'm going to do the 10 times 12, which is 120. So the area of this rectangle is 120 centimeters squared, right? Area of any triangle is 1/2 base times height. What's the base of this triangle? 12. If that's 12, that's 12, right? What's the height of this triangle? 6. Very good. If this is 16 and this much is 10, then this had to be 6. So we just said 1/2, 12, 6. So what is 1/2 times 12 times 6? 36. So the area of the triangle is 36. So my total area is 120 plus 36, which is obviously 156 centimeters squared. Is that okay? A lot of people in the other classes were asking how much of that they have to write down. I don't care, but these can get kind of tricky, so I find that the more specific you are for yourself, like area total, area triangle, the less likely you are to get it wrong. If this were a test or quiz and all you had was a wrong answer and nothing else, I couldn't help you. But if you at least had this is 120 and this is like 32, I can give you half credit because you got half of it right. Do you see what I'm saying? So I find that it's better to write it down, but I'm not going to count off if you don't unless you're wrong. Okay? All right, on the next picture, what shape is this? A rectangle. Thank you for not saying a square. It's a rectangle. Very good. What exactly? What shape is this? Probably a rectangle, I think, maybe. I'm not sure. What's this? Say it again, Jordan. A quarter of a circle, right? This is a quarter of a circle. If I were to do half a circle, it would look like this. 3/4, and a whole thing. This is a fourth of a circle. Do you guys see that? So the area of my circle is going to be a fourth pi r squared, because the area of a circle is pi r squared, but I have a quarter of a circle. Does that make sense? Okay. I'll come back and finish that later. I just want to write it down while I'm thinking about it. So let's find the area of this rectangle. What's 3 times 3.5? 10.5. If it's that easy, I'm okay with you just kind of like writing it in there. If you want to write it down like I did on the last one, fine. Did we ever figure out what shape this was for sure without guessing because it looks like something? We know this is 5.5. I need this. Don't say anything out loud for a moment. I want you to look at the picture and try to figure out what this is. There's no math involved. You just have to look. Okay? What do you think? What do you think? Yeah? 3.5. It's one or the other, right? You guys got to pick. So let's look at this. If this is 3.5, what's this? 3.5, right? This is the radius of our quarter circle. This is the radius of our quarter circle. So what's this? 3.5. So what's this? 3.5. Do you guys see that? Super easy now, right? So it's 5.5 times the 3.5. Very good, 19.25. So now all I'm missing is this quarter circle. So if we just said again, the radius was 3.5. So I'm going to take 1/4 pi 3.5 squared. Leave it in your calculator, but what do you get? 9.6-ish something, right? Keep it in there though, right? And we're going to add the 10.5 and we're going to add the 19.25. And our total is what? Excellent. 39.4 millimeters squared. Take your time and get there. Okay? So sometimes we don't actually have to store it. If we're smart about the order that we put it in, like we had the area of the circle and we just left it in the calculator, and then we added the 10.5 and the 19.25. Did I lose anybody? Anybody not get it right? Are we okay? Okay. Last question. Find the area of each shaded region, round to the nearest tenth. This is like in your homework the other day where you guys had like a, I think maybe a square with like 2 circles cut out, right? So we want the area of the tannish orange piece. So the area of the total, or the shaded region, is going to be, how am I going to find it? I'm going to find the area of what? The circle, and I'm going to do what with the area of the triangle? Subtract the triangle. Do you guys get that? So again, do you have to do this to get it right? No, but I find that in a question like this, it's very easy to get lost inside of it. So I find that having that as like kind of my roadmap of where I wanted to go in the beginning kind of like lets me get back on track. Okay, so obviously the area of a circle is pi r squared. Do I have the radius? No, so I'm going to have to come back to that later. Typically the area of a triangle is 1/2 base times height, but I can't do that either, right? So I'm going to have to do 1/2 PA, 1/2 perimeter times apothem. This is a regular triangle. It looks equilateral. They should have said that, but it is. Okay. So what do I know? So what's that lead me to know? The perimeter, right? What's the perimeter of that triangle? 6, right? 2, 4, 6. So that's half of what I need. So that's good. Now I'll have to go back and find the area or the apothem in just a second. Okay? So whenever you're finding the apothem, the first step is to find the central angle. If you remember, the central angle is 360 over number of sides. Central angle is going to be 360 over 3, which is 120. So this angle here is 120. Is everybody okay with that? Okay. From there, I'm going to look for the apothem. I don't know what it is, right? This is my apothem. This is confusing for me. So I'm going to draw a picture. I've got 120, I've got apothem, and I have a 2 feet for the whole thing. Is that okay? For me, again, I pulled that picture apart. So one more time, you don't have to do everything I do. If you're fine with just going to the half part, or you can look at the original and be fine, that's great too, but it's too much for me. So this is 120, what's this? 60, this is still my A, what's this? It was 2, so now it's 1. Everybody okay with that? Okay. So you can do 30, 60, 90 if you'd like. I find that most people probably prefer SOHCAHTOA because it works all the time, right, with right angles. So if you're going to do 30, 60, 90, you go right ahead. I'm going to do SOHCAHTOA. I typically only do the shortcuts if I have to, or if it's a 45, 45, 90, because I think that one's pretty easy. But 30, 60, 90, I feel like even though you're supposed to know it, people kind of forget which part goes where. But SOHCAHTOA, you guys are pretty good at. Okay? So I've got 60, I've got the 1, and I've got the A. What is the 1 called? Opposite, adjacent, or hypotenuse? Opposite, what's the A called here? Adjacent, so we're going to use tangent. Tangent of the angle equals opposite over adjacent. So that'd be tangent of 60 equals 1 over A. Is everybody all right with that? So you multiply by A and you divide by that tangent of 60. So it's going to be A equals 1 over tangent of 60. And you're going to find the apothem for me. You're going to keep it in your calculator. What do we get? Yeah, I wrote 0.6. Okay. So I'm not going to use 0.6. I'm going to use this stored number. You're going to have to store this one. We're going to come back to it later, and you're not going to be able to grab it unless you have a calculator that does that, right? So that 0.6 whatever, we're going to have to store. Or write down like 5 decimals. Okay? Either way. All right? So I'm not going to find this yet because I still need the circle. What piece of the circle am I missing? The radius. Like this or this, which would be this or this, which would be this. SOHCAHTOA again, or Pythagorean theorem. I'm not going to choose Pythagorean theorem because then I've got to use that A that I just stored. I find most people get confused by that, but you could, totally could. So I'm going to do SOHCAHTOA again. So I'm using the 1 and the R this time. So that's opposite hypotenuse. So sine of A, nope, sine of 60, excuse me. Sine of 60 equals 1 over R. Multiply by the R, divide by the sine of 60. So R equals 1 over sine of 60. Find R. I got 1.2. Okay. Keep it in your calculator. You don't have to store this one, but if you're used to storing buttons, storing numbers, that's fine. So I'm going to plug it in. It should still be in your calculator, right? So the area of my circle is going to be whatever that 1.2 squared is times pi. So take your 1.2 squared times pi. And what's the circle give us? No, I didn't get that. Yeah, I got like 4.2. Okay. And we're going to use that to subtract whatever we get for the triangle. So we kind of have to store that too, right? So whatever you get here, goodness, that 4.2 something, you really do need to store it right down like 5 decimals, okay? And now we're going to see what this is. So it's 1/2 times 6 times the 0.6 from before. Say it again. I got 1.7. Is that not what you got? Did you use the 0.6 that we stored, or did you use 0.6? Yeah, don't use 0.6. Use the 0.6 that we stored. Okay? Okay, so we should end up getting 1.7-ish, right? So we're going to use the 4.2 stored minus the 1.7 stored, and technically our answer should end up being 2.5 feet squared. I know that the storing seems tedious, I know that, but as you already saw, just by rounding one thing, we already were off by a tenth. And then you round another thing, you're possibly off by a tenth. So someone in the last class used all rounded answers, and they were off by like a lot. I think our answer was 2.5, and they have like 2.8, which I know doesn't seem like a big deal, but if you're building my house and you're off by that on every corner, my house isn't going to look right. Do you see what I'm saying? So again, if the storing is the issue, then don't worry about it. Just write down 6 or 5 decimals. It's fine. Okay? Anybody have a question anywhere, or it's not working for you? Okay, so remember, I've got the answers. They're on Harmony under today. If you don't know how to find those, let me know and I'll help figure it out for you. Okay?